Problem 21, find the integral of the cotangent of 7x. Well, hopefully you remember that if you have the integral of cotangent u, the integral will be natural log of the sine of u. But you'll notice we do have to do a u here. So I'm going to let my u be 7x, and then my du will be 7 dx. I'm missing the 7, so I'll put a 7 on the inside. Undo it with the 1/7 on the outside. So if I rewrite this, I've done nothing with the cotangent, so it's still there. Cotangent u, and then everything else turned into du. And now I could just use that formula. It's just going to be 1/7 natural log of the sine of u plus c. And that's really all there was to it. And that should be option A. Okay, problem number 22. This asks us to evaluate an integral. What we are going to do on this one, because we do have a fraction, I'm going to bring this up to the top, and when I do that, I'll have x squared minus 2x times x to the negative 1/2. Notice there's a times there. We don't make it plus, right? Now what I'm going to do is distribute that to both parts, and when I do that, I will add the exponents. Right, so x to the 2 and x to the negative 1/2 will be x to the 3/2 minus 2 x to the 1 and x to the negative 1/2 would be x to the 1/2. And since there's a minus sign, we can go ahead and treat both of them as two separate integrals. And for each one of them, I will increase my power by 1. So 3/2 plus 1 will be 5/2, and I do the reciprocal on the outside, so it will be 2/5. And then minus, I'm just going to bump my 2 out front there. If I add 1 to that, I'll get x to the 3/2, and then on the outside we'll put 2/3. And then just cleaning this up a little bit, I'll get 2/5 x to the 5/2 minus 4/3 x to the 3/2 plus c, and that would be my integral. Okay, 23, find the absolute maximum of ln x plus 1 on the interval 0 to 3. First of all, if I'm looking for a maximum, I am looking for a y value, and I'm looking for the highest y value that I'm actually absolutely going to get. So the first thing that I want to do is get a critical number. So critical number, the way I'm going to get the critical number, of course, is take the derivative. And remember, if I have an ln, my derivative is just du over u. So the derivative of the u would be 1, and it's going to be over x plus 1. So that's my derivative. If I set it equal to 0, notice the numerator is never going to equal 0, but the denominator will equal 0 when x equals negative 1. So that's my critical number. Okay, the next thing that I want to do is we're not going to draw a chart this time because we're looking for y values. So I'm going to test my critical number and my endpoints. And I'm going to test them in the original because I want the original y values. So I'm actually going to find f of 0, I'm going to find f of 3, and I'm going to find f of negative 1. And when I do that, when I plug 0 into that formula, I'll get the natural log of 1, which is equal to 0. On this one, I'll get the natural log of 3 plus 1, which is the natural log of 4. And when I plug negative 1 in, I'll get the natural log of 0, which is undefined. So if I'm looking for an absolute maximum, which one of these y values is the highest? And that will be the natural log of 4. So it occurs at x equals 3, but the actual maximum is the natural log of 4. Okay, problem 24 is asking me to find the derivative of this formula. And I notice that I have x's and y's, so I am going to use implicit differentiation, which basically just means wherever I see a y, I need to make sure when I take the derivative of it, I do dy dx. All right, this first part right here, I do notice that I have two functions being multiplied together, so I'm going to use the product rule. F prime will be 2x. G prime, the derivative of e to the y, is just e to the y, but I do also have to include the dy dx. All right, so using the product rule for that, f prime g, so 2x e to the y plus f g prime x squared e to the y dy dx, and then minus the derivative of 3e to the 2x would actually be 6 e to the 2x because I do have to multiply by the 2, the derivative of the power, and then plus 2y, and then I do also again have to include that dy dx, and then equals the derivative of 7 is 0. Okay, everything that has a dy dx stays on the left side, everything else moves. So we're going to have x squared e to the y dy dx plus 2y dy dx equals 6e to the 2x minus 2x e to the y. So we just got rid of those on the left side, and they are now on the right side. Okay, next thing that I would like to do on the left side is factor out a dy dx. So I then will have x squared e to the y plus 2y, and then it will equal 6e to the 2x minus 2x e to the y. And then to get dy dx by itself, we will simply just divide both sides by the part next to the dy dx. So my final answer, dy dx, will equal 6e to the 2x minus 2x e to the y all over x squared e to the y plus 2y. Okay, problem 25. If f is equal to the integral from 1 to x, find f prime of 2. So once again, this is asking me to find the derivative of an integral. And the derivative of an integral just cancel each other out. So the derivative is just going to equal this same thing, but we always replace the t's with whatever variable's up there, which happens to be an x. So this is going to be 3x squared plus 4x plus 1. So we found the derivative. This asked me to find the derivative at 2. So if I find the derivative at 2, simply just plug 2 in for your x value. And when I do that, I'll get 12 plus 8 plus 1. That gives me 21. Okay, problem 26 asks me to find the derivative of this natural log function. I do know the derivative of natural log is du over u. This looks like a mess, and we're going to clean it up before I even try to work this out. So this will be the natural log of the square root of 4x plus 1 minus the natural log of x cubed plus 5 cubed. And then from here, I don't like working with all these powers, so I'm going to bump the powers out front. So this would be a 1/2 power. So we'll have 1/2 ln 4x plus 1 minus 3 ln x cubed plus 5. And our life has just gotten a ton simpler. So now we're ready to take the derivative. The 1/2 just tags along. The derivative is just going to be du over u, so it will be 4 over 4x plus 1. And then minus, that 3 just tags along. The derivative, it will be du over u, so it will be 3x squared over x cubed plus 5. All right, let's clean this up. This 2 and the 4 will cancel, so I'll be left with 2 over 4x plus 1. And then minus, if I put a 1 under the 3, multiply across, I'll get 9x squared over x cubed plus 5. And then I suppose I could get a common denominator here. The common denominator would be 4x plus 1 and x cubed plus 5. I'd have to multiply this one by 4x plus 1 over x cubed plus 5 over x cubed plus 5. That would give me 2x cubed plus 10. And then this one I'm going to have to multiply by 4x plus 1. 4x plus 1. This minus sign distributes, so I'm going to get minus 36x cubed minus 9x squared. And then from here I'm going to combine like terms. 2x cubed minus 36x cubed would be negative 34x cubed minus 9x squared plus 10 all over the common denominator of 4x plus 1, x cubed plus 5. And then voila, we are done. Okay, 27, evaluate. On this one, if there is more than one e in the problem, I always let u be a chunk. So I'm going to let u equal e to the x plus 5, which means the derivative is going to be e to the x dx. And I notice that is just nicely in my problem, so I'm going to rewrite it. So I notice that my chunk is on the bottom, and everything else turned into du, and du is always in the numerator. So the integral of du over u is just the natural log of u. And then I do have to evaluate it at 2 and at 0. So if I plug 2 in, I'm going to get the ln of e squared plus 5. And then minus the ln, if I plug 0 in, I'll get e to the 0 plus 5. And then simplifying this, I'm just going to get rid of my absolute values on this one because that will be a positive answer. And then minus the ln, e to the 0 is 1, and 1 plus 5 is 6. So that would be what my answer looks like on that one. Okay, 28. Find the derivative of arc sine. I do know that the derivative of arc sine is du over the square root of 1 minus u squared. So let's just work this out. 3 just tags along. And du, the derivative of 2x minus 1 would be 2. And then over the square root of 1 minus 2x minus 1 quantity squared. And then from here, the only thing that I would really need to do is let's multiply the 3 and the 2 together. So I'm going to get 6 over the square root of 1 minus quantity 2x minus 1 squared. And we would be done. Okay, problem 29. Find the derivative once again. All right, this one I recognize as a to the u, and the derivative of a to the u is a to the u du ln a. Okay, so that's what I'm going to tackle first. So this first part, a to the u is just going to be 4 to the 2x times the derivative of the 2x, which is 2, times the natural log of the base, which is natural log of 4. So that one is done. Okay, and then minus, this next one is a log problem, and I know the derivative of log is du over u times ln a. Okay, so that's the formula I'm going to use. So my du will be 5 over u, which is 5x, times the natural log of a, times the natural log of 3, because 3 is the base. All right, the only thing that I could do from this one would I could cancel my 5's, so really, and that is just it. So I'm going to have 4 to the 2x times 2 ln 4 minus 1 over x ln 3. And I'm just going to be happy with that answer the way that it is. Okay, problem 30. Evaluate 1 over 9x squared plus 4 dx. I could try to do a u substitution on this one, but I would not have du in my problem. So I do notice that it does look like an arctan problem because it's in the form du over u squared plus a squared. And when I do that, I know I'm going to end up getting 1 over a arctan u over a. So that's what I'm going for here. I just need to identify my parts. My u would be 3x, which means my du would have to be 3 dx, which notice I have the dx, of course. I'm missing the 3, so I'll put a 1/3 on the outside to make up for that. And then my a would be the square root of 4, which is 2. So all of my parts are there. So I'm going to have 1/3 times 1 over a, so 1 over 2, arctan u over a. And then I'm just going to clean that up a little bit. There'll be 1/6 arctan 3x over 2. And instead of putting plus c, I will evaluate it at 0 and 2/3. So if I plug 2/3 in here, I'm going to get 1/6 arctan. 3 times 2/3 is 2, divided by 2 is 1. And then minus 1/6 arctan. 3 times 0 is 0, divided by 2 is still just 0. So from here, the arctan of 1, I'm thinking the sine of what over the cosine of what would equal 1. And I know that that would be pi over 4. So this part's going to be 1/6 times pi over 4, which gives me pi over 24. And then minus arctan of 0, I'd be looking for the sine of what over the cosine of what would equal 0, and that would equal 0. So my answer for that one would just be pi over 24.